What if I were to tell you that this alien megastructure could be real?
A Dyson structure is very much like a solar power plant, but billions of times larger, in space, orbiting an entire star.
And there could even be one in our own galaxy.
Whatever was crossing in front of this star was not circular like a planet.
Get ready, because this is some seriously weird science. Okay, I know what you're thinking. Aliens have a very unscientific sound to them. But the idea that we are not alone in the universe is mainstream scientific thinking. And here's briefly why. Our little life-supporting Earth orbits one star, the Sun, in our solar system. And it may well be the only life-supporting planet there. But our galaxy, the Milky Way, is home to up to 400 billion other stars. And a recent study has estimated that there could be 6 billion Earth-like planets among them. And, yeah, there's more. Our galaxy happens to be just one of an estimated 2 trillion other galaxies in our universe, each containing billions more stars and billions more Earth-like planets on which life may have formed. And that's why for many scientists this changes the question from does alien life exist to where is it? And what would an advanced alien civilization look like? We've heard a lot about searching for life on Mars, but it's probably going to be a lot harder to spot a lonely bunch of single-celled organisms huddled on a cold, dark rock in space than it would be to spot an advanced civilization capable of complex technology and communication. So, astrophysicists started imagining what that advanced civilization might look like. And the distinguished Russian astronomer Nikolai Kardashev went a step further. He developed a system to describe how technically advanced a civilization is.
A Kardashev Type 1 civilization is a civilization that's capable of harnessing all of the energy that falls on their planet from their parent star.
So, where do you think we are on this scale?
Our sun's power output is 400 billion terawatts. Human civilization today only consumes about 20 terawatts of power. That's about 1/1000th of the amount of energy that falls on our planet from our sun.
And that makes us, with all of our amazing technology, a Type 0 civilization. So where does this come in? In order to achieve Kardashev Type 2, a civilization would have to be able to harness 100% of the energy of its closest star. And that's when astronomers started to imagine something like this.
A Kardashev Type 2 civilization would need to build a massive network of solar collectors that would orbit their star in space, something we call a Dyson sphere or a Dyson structure. A Dyson structure is very much like the solar power plant here, but billions of times larger, in space, orbiting an entire star. But they needn't be a solid surface. It could be a swarm of individual solar panels, all interconnected as long as they occluded a large fraction of the light that came from the star.
And if you could build this type of megastructure around one star, copy and paste. A Type 3 civilization would apply this to the next nearest star and the one after that until it's able to harness the energy of an entire galaxy. Okay, let's dip back into the realm of feasibility here. In order to make one Dyson sphere, it requires engineering on a truly and very literally astronomical scale. It would require all of the matter from all of the planets in our solar system. That's why a Dyson sphere is still totally theoretical. But then some strange observations from space made us question if, despite all of this, we might actually have found an example of one in our galaxy. So in 2013, these strange signals came from some data from NASA's Kepler space telescope.
Kepler looked at over 150,000 stars in our galaxy, and the data for this star looked nothing like any of those stars and nothing like any other star that we know of today.
They'd been searching the Milky Way for exoplanets, which can usually be detected because they dim the light in a clean, predictable way each time the exoplanet passes in front of the star.
So this is what a exoplanet transit looks like. On the left-hand side, you have the amount of light, and on the bottom, you have time. And when a Jupiter-like planet transits in front of a star, you have this clean U-shaped dip in the star's light. And this dip is about 1%.
But the star Tabitha Boyajian was looking at was unlike anything they'd seen before. Something strange and irregular was passing in front of it, sometimes making it dim by as much as 20%.
You have this dip that, on face value, it appears to look like what a transiting planet would look like. But if you take a closer look, then you actually see that the transit lasts for almost a week compared to what a planet-sized object would just last for a couple of hours. It was also very asymmetric in shape, meaning that instead of having that clean U-shaped dip, it had this strange slope over here on the left-hand side. This seemed to indicate that whatever was crossing in front of the star was not circular like a planet. And the deepest one here drops by over 20%. And so it seems to indicate that there's some swarm of objects with different sizes and shapes that were passing in front of the star.
Could it be the irregular pattern of some form of Dyson sphere harnessing and dimming its light?
In the 21st century, we'll find out about life at the galactic scale.
The excitement and mysteriousness of Tabby's star sparked an even more extensive search for alien life.
Now, if Tabby's star does indeed have a Dyson sphere around it, and it is inhabited by a very advanced civilization, we could detect it with this telescope.
Using the gigantic 100-meter Green Bank radio telescope, in 2016 the team tracked Tabby's star, scanning billions of radio channels simultaneously in search of unusual anomalies, making it perhaps the best chance humanity has ever had to make contact with an advanced civilization.
This evening is a very exciting night. We've been waiting for it for over a year, so yeah, I think we're all pretty excited about what's happening.
What's next? Does Tabby start next? All right, it's time for you to push the button.
All right, here we go.
If there was evidence of technology in these data, what we would expect to see is a spike in one of these plots. Now, we don't see that yet, but in the coming days, weeks, and months, we're going to be looking at these data in many different ways that will allow us to be much more sensitive to evidence of technology.
Okay, so since this huge search took place, there's been an updated theory as to what caused the dimming from Tabby's star. And spoiler alert, it's not an alien megastructure. Astronomers now believe that it is clouds of space dust that have come from a moon that's been ripped apart. So, not uninteresting, but not an alien megastructure. But the mystery around Tabby's star reminded us of the different ways that alien life can present itself. And we've since found other stars with strange dips in light. So while Tabby's star probably doesn't have a Dyson sphere surrounding it, the search is far from over.
I don't know if they're out there or not. As a scientist, I have to admit that. But I think that it would be a pretty strange universe in which life only arose once and intelligence only arose once.